Very good morning. Today we'll be solving exercise 10, question number 2 and question number 3. In last talk of ours, we talked about one way within subject ANOVA. We did the example question and exercise 1 question and has given you question 2 and question 3 as assignment. Today I'll be just solving those two questions on assignments, that is question 2 and question 3. Look at question 2 first. If you look at the question, here we are talking about a clinical psychologist wanted to investigate the effectiveness of psychoanalytic therapy over time. 15 people who checked into the treatment facility and consented to participate were enrolled in the study. Each of the participation received psychoanalytical therapy for a period of 8 weeks. To measure the effectiveness of the therapy, the participants were administered a general measure of well-being before beginning therapy, 4 weeks into treatment, and after 8 weeks. The well-being measured ranged from 10 to 50, with higher scores indicating greater well-being. The data are in file exercise 10.2 SAV. The variables are named before therapy, 4 weeks and 8 weeks. We are to open the data file in SPSS and perform the appropriate analysis to answer the questions. The questions are, we have to state the null and the alternate hypothesis. We have to state the research question. We have to see, is there a significant difference in the well-being scores over time? We have to test alpha at 0.05. We have to find out the effect size for the ANOVA. We have to, you can say E part I'm talking about. If the overall ANOVA is significant, we have to perform a follow-up test as appropriate. We have to adjust alpha for each test so that the set of tests does not exceed 0.05, and we have to write the results of the study. So this is the question given to us. What I'll do is I'll be just talking a little about the question again. So the question is basically about a clinical psychologist who has been investigating the effectiveness of psychoanalytical therapy over time. So this time he has got 15 people. So respondents are 15, and these 15 people are going through the psychoanalytical therapy, and they are being measured. Um, you can say how effective the therapy is once before the therapy starts, second midway, that is after the 4 weeks of therapy, and lastly after completion of therapy, that is 8 weeks. So we are measuring the data 3 times. So if you look at the question here, the independent variable happens to be time, which has got 3 levels, and 3 levels are before, after 4 week, after 8 week. And dependent variable is the effectiveness of psychoanalytical therapy, so which is a continuous data, and this happens to be a dependent variable. So we have to state the null and alternate hypothesis. Just to tell you all that whenever we are talking about null and alternate hypothesis, null is something which says that there is no significant difference. So here we are saying that there is no significant difference as far as the effectiveness of psychoanalytical therapy is concerned over time, and this means mean of the people who have gone for the therapy before the therapy is conducted is equal to the mean of the same people who went for therapy after 4 weeks is equal to the mean of therapy of the same people after 8 weeks. Whereas the null alternate hypothesis here is going to state that at least one of the 3 values will differ from the remaining 2. This means that either before is not equal to after 4 week and after 8 week, or maybe after 4 week is not equal to after 8 week or before, and likewise there can be a probability that all the 3 values are also different. So any of the conditions which comes up here will be simply supporting the alternate hypothesis. So that is how we have stated the null in the alternate hypothesis. The research question for the data is that is there a significant difference in the effectiveness of the cycloidentical therapy for the different time frames of therapy, that is before, comma, 4 weeks, comma, 8 weeks, question mark. So this is how you can say we've answered A and B part. I'll be just repeating A and B part when we'll be looking at all the answers. I would request you all to just share, you can say move to the new things. And now we are moving to the question itself. So I'm sharing you the question part. So this is where the question comes, and this is how you can say the question is. So if you look here, we have got, you can say, the three you can say uh, things, that is before therapy, 4 weeks and 8 weeks. So this is the data given to us, and this is the variable view if you look at. So we have got before therapy, and this is basically a scale variable. 4 weeks again a scale variable, 8 weeks is again a scale variable. So that's all given in the question itself. Now we are going to conduct one way within subject ANOVA. And how are we going to conduct? We all are already aware that we have to first click on analyze. We have to click on the general linear model, move to repeated measures, click on that. As soon as you do it, you come up with this particular box. Instead of factor 1, or you can say uh, factor happens to be time, which is independent variable, and that is having 3 labels: before therapy, 4 weeks into therapy, and 8 weeks into therapy. So that's there. I'll add it. I'll define it. We have the another box coming up. Here we have got the 3 variables. I'm selecting all 3 of them, moving it to the right hand top box. Here I get all the variables. I click on options. I click on descriptives and estimates of effect size. I click on continue, and then I click on OK. The moment I do it, I'm moving to my new slide. Sorry, new, you can say file, that is the output page. So I'll be just showing you the output page, which I have received. So this is the output page I've got, and all this data I've got from, you can say, the question that I've done. So before therapy is given as 1, 4 weeks as 2, and 8 weeks as 3. Descriptive, which is coming up for before therapy, it is 24 something with a standard deviation of 7 something. 4 weeks, the mean, you can say, effectiveness level is 25 something, and the standard deviation is 6 something. Whereas after 8 weeks, it is 25 something, and the standard deviation is 8 something, 6 something, 6.8 something. So that's given to us. Talking about, you can say, the test that we are going to conduct. Um, and look at. So we are basically looking at, you can say, the greenhouse geyser, you can say, value, and DF actually happens to be 1.495. The mean square value is 3.953. F value is coming to 1.117. Now, if you look at the F value is coming to be very, very, you can say, low, and therefore the P value or significance happens to be 0.330. This means that when I'm talking about the 3, you can say, 3 three, you can say, means before therapy, 4 weeks into therapy, and 8 weeks into therapy, though the difference is there in the mean, is actually mean value is actually rising, but this rise is not significant enough to give me any significance or conclusion that okay, fine, there is a significant difference between the 3 values. So I'm not accepting the alternate hypothesis. I'll remain with the null hypothesis, and that is what is just to be done. And generally, if you have seen, you can say, when we were doing the examples and exercise 1 question, after, you can say, going for one way within subject ANOVA, that is GLM, we went for something called um, paired sample t-test also. But since here the greenhouse geyser, you can say value here or significance is not coming, there is no justification of, you can say, going for the one sorry paired sample t-test. So we are not conducting it. So this is the data we have got, and I've just copied all the data. So I'll be just showing you, you can say, the concluding file, or concluding, you can say, pages on what we have done. So coming up here, we are talking on the things. So I'm sharing you the file here, and this is what we are going. So for question 2, I'm just showing you the things. I'm again repeating the things. State null and alternate hypothesis. So I say that null is mean before therapy is equal to mean 4 weeks is equal to mean 8 weeks. And that is all already, we can say, already spoken, that whenever we are talking of null hypothesis, we are saying that there is no significant difference. So there is no significant difference as far as the effectiveness of therapy is concerned, whether it is before the therapy, 4 weeks into therapy, or 8 weeks into therapy. The alternate hypothesis says that at least one of the mean is different from the others. So that is what alternate is. And coming to the research question, this research question I've already spoken. Is there a difference in the well-being of people before 4 weeks, before over 4 weeks and over 8 weeks of therapy? So that's the question. So I'm just writing something here. I'm saying, is there a significant? So that is to be mentioned. Is there a significant difference, you can say, in the well-being of people before 4 weeks, uh, and over 8 weeks, before 4 weeks and 8 weeks of therapy? So that is what the research question is. Now coming to C part of the question, the C part of the question is that, is there a difference in the well-being over time, with alpha is equal to 0.05? So if you look at the answer, the difference in the well-being of the people, people before over 4 week and over 8 week of therapy is not significant at greenhouse geyser adjusted value f within brackets 1.495 comma 3.953 is equal to 1.117, and p is, you can say, greater than 0.05. So this being the case, we are not accepting the, you can say, the null hypothesis. Sorry, we are not accepting the alternate hypothesis, and we say that there is no significant difference as far as the well-being over time is concerned, and therapy is not having any significant impact on people's well-being. And now talking about the effect size. So for effect size, we all know partial eta square is the uh, thing we'll be talking about when it comes to ANOVA. And the formula is this. So I've used the formula, put down all the values, which you can look from the uh, previous topic when we were talking about the output file. And it comes to very, very low value, 0.013. So it's quite, effect size is quite minuscule. I won't even say small. It is quite minuscule. And if you look at, you can say the answer for E part. E part says, if the overall ANOVA is significant, perform follow-up test as appropriate. Adjust an alpha value for each test so that the test sets does not exceed 0.05. Now, look at the point here. Since the overall ANOVA is not significant, there is no need to perform paired sample t-test. So I know it that there's no use of performing, because already we know that the three, you can say, levels are not much significantly different. Rather, they are quite similar. And since um, we are accepting the we are accepting the null hypothesis, so there is no need to conduct paired sample t-test. And the final result which I'm putting up here is the same one which I've put for C part. But the thing is that, okay, here I've mentioned partial eta square also. So difference in the well-being of the people before over 4 weeks and over 8 weeks of therapy is not significant. At greenhouse geyser adjusted, F at 1.495 and 3.953 is equal to 1.117. P is greater than 0.05, and partial eta square is 0.13. So one thing we have known from this question, that as far as this cycloidentical therapy is concerned, and we have seen that the well-being of people does not differ much, whether you can say we are talking of before, or we are talking of something you can say with in between, that is 4 weeks, or after the completion, that is 8 weeks. So not much of, you can say, mean values is changing. The well-being of people is not increasing, and therefore we don't suggest that there is any significant impact of this psychoanalytical therapy. So that's the answer. So we've answered question 2, and we have done that. So just having a break for a minute. So I'm just moving to the previous share of going for question number 3. So we'll be just sharing question number 3 on the subject. So I'm going for share. And here we are having this question number 3 mentioned. So look at the question number 3 now. A marketing researcher investigated the impact of offering different types of Wi Fi internet services on the likelihood of eating at a fast food restaurant. So, this is given to us. And then, when we look further, we see it, the likelihood of dining at fast food restaurant was investigated under three different classifications: free Wi-Fi service, pay per use Wi-Fi service, and no Wi-Fi service. So we had 10 people were selected who ate fast food at least once a month, and they were asked to rate on 1 to 10 scale the likelihood: 1, the least likelihood, and 10, the greatest likelihood. So um that they would dine at fast food restaurant in each of the three conditions: free Wi-Fi, pay per use Wi-Fi, and no Wi-Fi. The data are provided in the file. So this file is with us, and the variables are named as free Wi-Fi, pay for Wi-Fi, and no Wi-Fi. So we have to open the SPSS file and perform the appropriate analysis. We have to also state the null and alternate hypothesis, state down the research question, talk about the significance at alpha is equal to 0.05. We have to talk about the effect size, and then we have to talk about, you can say, that if the overall ANOVA is significant, what test we have performed later on, a second test, and maybe you can say what is the adjusted alpha that we have taken up, so that the total value does not exceed 0.05. And finally, we have to write down the final interpretation in the APA format. So repeating the question again in a way where it becomes easy for us to assimilate and understand what this question is. So we are talking about a fast food restaurant. The fast food restaurant is trying to work on um, work on with the Wi-Fi policy, that should they have a Wi-Fi in their restaurant. So they got for 10 customers, and these 10 customers were asked question pertaining to three situations. Situation one, that free Wi-Fi is available at the fast food restaurant. Situation two, that you have to pay for the Wi-Fi which you are using. And situation three, no Wi-Fi. Now, these 10 people who are regular customers at the restaurant were to answer in a scale of 1 to 10. That one is that, okay, the least likelihood of having eating at the restaurant, and 10, high or the most high likelihood of eating at the restaurant. So these are, you can say, this was the question given to us. We have to actually see that, okay, is there a significant difference in the likelihood of people eating at the fast food restaurant dependent on the um, Wi-Fi options that we have got. That is free Wi-Fi, or pay for Wi-Fi, or no Wi-Fi. So that is what the actual, you can say, question basically here is. So talking about A part, where we have to state the null and alternate hypothesis, we know you can all answer the question, and it's simple, because in null hypothesis, we are simply saying that mean uh, free Wi-Fi is equal to mean pay for Wi-Fi is equal to mean uh, no Wi-Fi. This means that whether you have a free Wi-Fi or pay for Wi-Fi or no Wi-Fi, there is not going to be a significant difference as far as people's dining at the fast food restaurant is concerned. If you look at the alternate hypothesis means that at least one of the values will differ. This basically means that people will either, you can say, have a higher likelihood of, you can say, dining in the fast food restaurant based on, you can say, the Wi-Fi facility being provided, being free or pay or no Wi-Fi. Now, coming to the B part, we are talking about the research question. So, what research question are we going to have? Now, research question I have been speaking again and again are fundamental to your answering the uh, the the uh, very question that is to be answered, or simply you can say just trying to know that okay, fine, what analysis is done. So, research question here is that is there a significant difference in the likelihood of people eating at the fast food restaurant dependent on the Wi-Fi options available. That is free Wi-Fi, comma, pay for Wi-Fi, comma, no Wi-Fi. So that is what the research question here is. So I'll again talk about the research question about A and B questions when we actually, you can say, comprehend the answers for C, D, E, and F. So let's move to, you can say, the file. So I'll be moving to near share. The I'm moving to the 10.3. Yeah. So this is the file I'm moving up. So this is file before you. And what I'll do is I'll just try to see that am I in the right frame and right things are done. So I'm just resetting. That's my own internal correction. Nothing to do with the analysis right now. Again, for compare means, at times you can say I solve the question before I attempt with you also. That is what I did here. So just coming to the file back, and here we have got three, you can say, three, you can say, levels of the independent variable. That is, we are talking about Wi-Fi. So free Wi-Fi is one label, second is pay for Wi-Fi, and third is no Wi-Fi. And this is, you can say, what people have scored. These 10 people have scored in a scale of 10. So they have scored this way. Done. And now coming, you can say, to variable view. So we have got the variable. The first is free Wi-Fi. It is in scale form. Same is for pay for Wi-Fi, again scale form. And lastly, no Wi-Fi, again in scale form. So that is how the things are given to us. Now let's do this question on one way within subject ANOVA. So we go for analyze, we go for compare linear model, and we go for repeated measure. We click on that. This box emerges. I know my independent variable is Wi-Fi. I'm mentioning it here. Number of labels is actually 3. I simply add it. Here, that is define comes. So I click on define. I get this new box where we have got 3 variables, the 3 levels of Wi-Fi here. So I shift it to the top box on the right side, move to options, click on options. We have descriptive here. We have estimate of effect size here. Click on both of them, click on continue, and here we go. We click on OK. And what we are coming up with is the output file, which I'm sharing with you. So this is the output file where we have got, you can say, the answers before me. So general linear model has been performed, and we have, you can say, 1 for free Wi-Fi, 2 for pay for Wi-Fi, and 3 for no Wi-Fi. So I'm having descriptive stats here. Free Wi-Fi, the mean score is 7. There is, you can say, a very high score, 7 with a standard deviation of 2.58 something. So this means, you can say, people are very likely to have, you can say, food at the fast food restaurant. Whereas for pay for Wi-Fi, it is just almost half. 3.8 is the mean here, and standard deviation is 2.29 something. So look at the difference. You can say Wi-Fi, actually, you can say, or free Wi-Fi is inviting more and more people, almost double to, you can say, what is it is, you can say, for pay for Wi-Fi. And when it comes to no Wi-Fi, I again find the value is 3.4, even less than half of what you can say free for Wi-Fi is. So maybe you can say I simply feel that for no Wi-Fi, the mean value is 3.4. standard deviation is 1.95, what I basically feel is that definitely you can say people are enjoying free Wi-Fi, and we'll have, you can say, a lot of customers there who will be willing to enjoy food at our restaurant, fast food restaurant. In case we are having a free Wi-Fi, then people, you can say, um, getting no Wi-Fi. So that's the thing. But are these mean really significant? Is the difference, you can say, very much to be taken up as accepting the alternate hypothesis? So that we have to see. But before that, let's look at, you can say, the data, the answers we have got. So if you look at, you can say, test for within subject effect. So we are talking about the greenhouse geyser. This is what we are talking. Degree of freedom, DF is 1.778. Mean square is 43.790. And look at the F value. F value is quite significant, 20 point something. So 20.531 to be specific is the F value, and significance is 0.000. So that's a very high significance that's coming up. So definitely you can say people who have answered, they have significant differences as far as, you can say, their option for Wi-Fi is there, and their likelihood of eating at the fast food restaurants there, which basically means that people, you can say, are more keen to, you can say, consume more food at a fast food restaurant when free Wi-Fi is there than people, you can say, who are not going to, you can say, when the Wi-Fi is not available, will find the people's likelihood of, you can say, eating at the restaurant will go down. And if you look at, you can say, the things here, since, you can say, a meaningful answer has come from this part, what I'll do is I'll move for the another test which is required to see that, okay, fine, is there a difference as far as the groupings are there? So three groupings are going to happen. One is no Wi-Fi, sorry, one is free Wi-Fi, and you can say pay for Wi-Fi. That's one grouping. Pay for Wi-Fi, sorry, no, I repeat again, the three groupings or three PS we are having is pay for, no, sorry, it's the three groupings are free Wi-Fi and pay for Wi-Fi, pairing two, free Wi-Fi and no Wi-Fi, and pair three, pay for Wi-Fi and no Wi-Fi. So these three groupings we are having. So for that, we have to do another test to see that, okay, fine, is there a difference coming up? So for that, we are going for paired sample t-test. And you all have done paired sample t-test previously also. So if you look at the compare means, here we are having, you can say, paired sample t-test. Just a point here, paired sample t-test is also known as dependent sample t-test. So whatever the case may be, we are going for paired sample t-test, which is also known as dependent sample t-test. Free Wi-Fi, okay, fine, that's variable one. I click on here. Okay, maybe you can say my, okay, fine. And then pay for Wi-Fi, that's variable two for peer one. For peer two, free Wi-Fi, and then maybe you can say and no Wi-Fi, that's peer two. Pay for Wi-Fi, and no Wi-Fi is my third, you can say, pair. So three pairs I've got. I'll simply click on OK. And if you look at, you can say we are in the output file itself. So maybe you can say this is what pairing we are getting. For pair one, when we are talking about free Wi-Fi and pay for Wi-Fi, there you can say T value is 4.9. It's something very high. And we have, you can say, significance of 0.001. And for peer 2, when we are talking about free Wi-Fi and no Wi-Fi, the T value is 5.245. And again, the significance is 0.001. Whereas for peer 3, when we are talking about pay for Wi-Fi and no Wi-Fi, well, fine, T value happens to be quite low, less than even 1, 0.802. And here you can see significance is 0.443. Now, if you look at here, these three values, this means free Wi-Fi and pay for Wi-Fi, there's significant difference. And free Wi-Fi and no Wi-Fi, there's again significant difference. But pay for Wi-Fi and no Wi-Fi, no significant difference prevails. One good thing that we have got here is that the total significance, if you look at, and we do the sum of all the three significances here, it's coming to 0.001, 0.001, and the last one is 0.443. So when you do the total, it's coming to less than 0.05. That we'll be accepting in our analysis. And now coming to the conclusion here, we'll be, you can say, just moving to the, we'll be just moving to the answers now. So I'll be sharing the new file with you, not the file, but just my responses for the third question. So I'm moving to the new share now, and something called, I'm moving to something called this file. It's before you, and here we go. Here we go. So I've stated, you can say the null and the altered hypothesis. It is visible on the screen right now before you. You know what the answers are. So not talking much here. Similarly, you can say state the research question for the data. Again, the things are mentioned here. Not talking much on that. Okay, now coming to the C part, which is the question which we need to, you can say, actually see. So is there a difference between, a significant difference, the likelihood of eating at a fast food restaurant based on the type of Wi-Fi service offered? Test at alpha is equal to 0.05. Look at the answers we are getting. The likelihood of eating at fast food restaurant is significantly different over the three types of Wi-Fi service offered. At greenhouse, geyser, adjusted F is equal to 20 point something. So it's coming to 20 point something, and P is definitely very low. It's actually, you can say, 0.00. So P is less than 0.05. That's one thing I'm saying. So the significance difference is being, you can say, accepted. Now we are talking of effect size. Effect size is given by this formula. We have talked about this formula so many times. I will not repeat it. And when I did the answer comes to 0.695. Effect size, you can say, for ANOVA, you can say, lies between 0 to 1, and more it is near to 1, the effect size becomes larger. Here, the effect size is nearly zero point 0.7. So this means there's a huge effect size, and we are simply, you can say, not only accepting the significance, but accepting the significance with a high, you can say, effect size also. Now, when we did the t-test or paired sample t-test, this is the answer we got. So if you look at the part E question here, so for E part question, we talked about, you can say, the test, and the test, you can say, is being adjusted for all the values being less than 0.05. That is what we have seen in the output file. So free Wi-Fi and pay for Wi-Fi, the t value was 4.951, and significance is 0.001. And if you look at, you can say, the free Wi-Fi and no Wi-Fi, and then you talk about, you can say, t value, it's 5.245, and significance is again 0.001. And pay for Wi-Fi and no Wi-Fi, when I was talking on that, I had, you can say, a high, you can say, 443. So high, you can say, when I was getting the data. So maybe you can say, I'm sorry, I'm just coming to this page, the actual page. So this is the value we are having. So it's basically 443. So I'm writing the right answer, 443. So this is what the significance is. And the total of these significance is less than, you can say, 0.05. Does not exceed means it should not be more than 0.05, but we are within that limit. And this is the adjusted alpha which I'm using. So everything has been shown. Just a line you can mention here that we have done paired sample t-test, which is also known as dependent sample t-test or repeated measure t-test. So that's there. And now coming to the final conclusion of the question. Here the question is, write the results of the study. Now the results are being written. The likelihood of eating at fast food restaurant is significantly different over three types of Wi-Fi service offered. Greenhouse Geisler adjusted, F is equal to 20 point something, and P is greater than 0.05. Partial eta square we have just calculated is equal to 0.695. Dependent sample t-test. Paired sample is also known as dependent sample. So dependent sample t-tests were conducted to assess which of the Wi-Fi options differed from one another, with each test conducted at an alpha level of 0.016. So this is clear to all of us right now. And the results indicated that likelihood of eating at a fast food restaurant was significantly higher for free Wi-Fi at mean of 7, SD of 2.58, with T at 9 degree of significance is A degree of sorry, at 9, a degree of freedom at being 9 is 4.95. P value is less than 0.016. Um, then for pay for Wi-Fi, M is equal to 3.80, SD is equal to 2.29, and also significantly higher for no Wi-Fi. Significantly higher uh, for then for say higher than for no Wi-Fi. So M is equal to 3.40, SD is equal to 1.95, and T at 9 degree of freedom is 5.24, with P you can say being less than 0.016. So that's clear to us. And also the last line, please remember it. There was no significant difference in the likelihood of eating at fast food restaurant for pay for Wi-Fi and no Wi-Fi option. So this is how you can say we have written the results for this question 3. I suppose you're understanding with example that I've shared with you the video, and you can say with what do you call it, the exercise 1 question, the video has been shared with you, and this is the final video of, you can say, exercise 2 and exercise 3, which I'm sharing with you. Your understanding of one way um, within subject ANOVA will increase, and more of, you can say, you have already done a session on this. So thank you, you can say, for watching these videos, and in case you have questions and issues, I would be happy to answer in the WhatsApp group or by email. So thank you. Thank you to all.